Okay, so we're going to have a look at the video on carboxylic acids, which is again a continuation of the organic chemistry topics, guys, that we have been doing. So again, just like the others, I will give you the page references that you would want to use for. So if I do the class notes, first of all, so by the end of this, you'll want to make sure that you've got the class notes covered. So page, it starts on page, in the class notes, page 20, page 24, and it's really to pretty much the end, and that brings us through to page 27. If I give you the textbook reference then, so make sure you've got all of the gaps filled into your class notes there. The textbook gives us page 210, and that runs then to page 214. And again, guys, please make sure that you're doing the little test yourself questions and the checkpoint questions as you go along to cover those. Okay, so if you want to make a note of that, just do, because I'm going to clear that off the screen now. Okay, so let's have a look at carboxylic acid. So you'll be pleased to hear that this is our last functional group, our last homology series that we're doing. These are carboxylic acids. You've met these before. They're very weak acids. Now, if you remember back in year 11, we did about acids and bases, and weak acids were ones which only partially dissociate when they're put into water. Okay, so but they will react in exactly the same way as strong acids. So strong acids were like our hydrochloric acids, our sulfuric acids, and our nitric acids, whereas our weak acids, our carboxylic acids, were ethanoic acid, methanoic acid, things like that. So they will react in exactly the same way as our strong acids, these carboxylic acids, but just more slowly. They'll give out less bubbling, they'll dissolve a metal, for example, a bit slower. They'll not produce as much heat as a strong acid would with something. We will get salts, okay, and you need to be aware of, they're pretty straightforward, the salts. When you've met a couple of them before, you've certainly met methanoate and ethanoates before. Just like our hydrochloric acid gives us, and I'm sure you remember this from chloride, just like our sulfuric acid gives us our sulfates, okay. Our methanoic acid gives us methanoates, that's the formula of it. Our ethanoic acid gives us ethanoates, that's the formula of it. So remember, these are -1 ions. So when we go to write the formula of the actual salt that's formed, if it was, for example, sodium ethanoate, that'll be NaHCOO, that's 1+, that's 1-. So it says, so if it was, for example, we'll do some of this later on anyway, magnesium ethanoate, okay, that's 2+, and that's 1-. So therefore this time we would need brackets and the 2 for the methanoate, or for the ethanoate, sorry. Okay, so that's an introduction to the salts, and you've met those before in writing. We'll write some formulas of them. Okay, right, so the carboxylic acids that you have to know, okay, are coming up on the board now, just like the structures that we've already had for our alkanes, and our alcohols. Okay, we've got to do the same for our carboxylic acids. So again, you'll have to know the molecular formula for each, and you'll have to know the structural formula for each. You can hopefully already see we have a new functional group. So our functional groups so far have been a carbon-carbon double bond for our alkenes. We have had a COH group for our alcohol in the last video. Now we've got C double bond O going down to a single bond OH. Okay, here is the functional group of all carboxylic acids. You'll see all of them have that. And we write it shorthand, we write COOH. It can also be written CO2H. You'll see that. Okay, but you'll always see this. This tells you you've got a carboxylic acid. Okay, and again, you'll have to be able to draw these out. So, same code as always. There's one carbon, meth. Okay, the carbon bonds in it, although there is only one, are all single bonds, so it's an. And the ending for a carboxylic acid is oic acid. Okay, so putting that all together, you get methanoic acid. Down here, same thing, 2 carbons, eth, all single bonds, and carboxylic acid, ethanoic acid. Okay, and all of these are liquids. So like our alcohols, they're all liquids. They've got much higher van der Waals forces than our alkanes and our alkenes. Okay, so propanoic acid and butanoic acid, those are the 4 that you have to know. Okay, you'll see here C2H5, that's referring to that group there. Now you could write that if you wanted, CH3, CH2, COOH, that would be fine. Okay, likewise down here for the butanoic acid, I could write that CH3, CH2, CH2, COOH, both the same. Okay, doesn't matter in terms of GCSE which one of those you wrote for the molecular formula really. Okay, it'd be fine for both. But again, there's the carboxylic acid functional group. Okay, in all of them, and then everything else you account for. Okay, right, dissociation. I've already mentioned that these are weak acids. Strong acids fully dissociate. So if I had a strong acid like HCl, every single molecule of HCl would decompose into H plus and OH minus. So if I have 1,000,000 particles of HCl, it's in a 1-to-1 ratio, okay, I will get 1,000,000 H plus ions. Weak acids only very partially ionize. So if I was, say, for example, if I had some weak acid, an ethanoic acid, 0.05% of it might ionize. So if I had 100,000 particles of this, okay, that would only give me 50 hydrogen ions. Whereas up here, if I had 100,000 HCl's, that would give me 100,000. Okay, 100,000 H plus ions would come from 100,000 of those. You can see why these are weak acids versus strong acids, but they still produce H plus ions, so therefore they still react in the same way as acids you would expect. Okay, hydrochloric acid turns universal indicator very red, deep red. Ethanoic acid turns it sort of orange. Sometimes it does. It's very hard to tell the difference with universal indicators. Right, let's have a look at the reactions now. The beauty of this, guys, is you've already done all of these reactions with strong acids, so the observations are the same, except it's just not quite as vigorous. The balanced symbol equations, we did quite a few of them in year 11, so hopefully some of you are relatively familiar with them. So let's think if we can remember what happens whenever we add a carboxylic acid to a metal carbonate or a hydrogen carbonate. See if you can sort of pause the video and come up with the observations. Okay, so there's one of the equations, that's with sodium carbonate. So if you couldn't think of the observations, maybe look at the equation now, pause the video, see if you can come up with the observations. Okay, well, hopefully you can see here, we've got carbon dioxide, that's a gas, so we will get effervescence. Okay, fizzing, bubbling, yeah? Okay, what else would you say? Well, you should say also that is a colourless gas. It is an odourless gas. And there's a space there. It's an odourless and it's a colourless gas. Okay, if the sodium carbonate is a solid, and it may be, the product of this, if you go to your solubility table, is aqueous. So your solid, another observation is that the solid will disappear. Okay, now be careful, because if the sodium carbonate at the beginning is aqueous, you dare not say that, because you will lose your mark. That just means that it remains colourless. This solution here is a colourless solution, so you would tell them that. Okay, it's a group 1, it's a group 1 sodium metal salt, so it's a colourless solution. Okay, and that's about it. You might be asked there also about the test for carbon dioxide to prove that this originally is a carboxylic acid. Okay, and you would test the gas given off with lime water, and if it turns lime water milky, it's carbon dioxide, which then you can backtrack and go, well, if it's carbon dioxide, that means that must be a carboxylic acid. Okay, so it's a good wee test for a carboxylic acid. with metal hydroxides. This is just acid plus alkali. Now there's not very much happening in here. You start off with a colourless solution, you end up with a colourless solution. The only observation really that you get here is you get a bit of heat given off. It's an exothermic reaction. Okay? You could say, I suppose, that this is a colourless solution, but it's a colourless solution to begin with. There's no fizzing or anything like that in this one. With metals, okay? Now, with metals, have a look at it, see if you can predict observations. It's the same as you had with strong acids, okay? We've got hydrogen, so we will get fizzing. The gas that we get has no colour, it's a colourless gas. It's an odourless gas, okay? My metal will of course be a solid to begin with. If you check out your solubility tables, you'll find that this is aqueous. So therefore your metal will disappear. Okay, this is a group 2 salt. Group 2 salts, you should know, are colourless solutions. So there's another observation. Okay, and this reaction is extremely exothermic. Metals reacting with acids are very exothermic. So you have loads of observations in that last one. How could you test for any gas? Well, you'll have a couple of tests there. I suppose I should have said that one there. That's your lit splint, your squeaky pop. So remember, lit splint, not a glowing splint. Okay, and that's your pop test. And then the carbon dioxide one is, of course, well, you should all know that. That's the lime water going milky test. Okay, so right, uses of ethanoic acid then. Okay, it's using vinegar, a very dilute solution of it in vinegar. And if you smell the ethanoic acid in the lab, you'll smell that it is very much of vinegar. Okay, right. So the last, I wanted to do just maybe a couple of reactions that weren't on that previous page there, guys, which we could do. Okay, this is one that pops up every now and again, not very often. So copper carbonate plus, well, let's take methanoic acids, doesn't really matter which acid. Now we would get copper, methanoate would be our salt, so okay, plus we get its carbon dioxide and we would get water. Remember, copper is 2 plus, methanoate is 1 minus, so we've got to go 2 there and then we balance that out by putting it 2 there. Now what observations did we get here? Well, observations exactly the same as we had on the previous one there. Okay, circle around that, we have a colourless and you have an odourless gas. Okay, so you get fizzing, I should say. Alright, now let's say our copper carbonate it's not soluble, so it's going to start off as a solid. We will get a solution. Now this is where you need to be a wee bit careful on this one. This is not a group 1 or group 2 metal. This is a transition metal, and you should know that copper solutions, okay, copper solutions are a little, have got colour, and this one this time we will get a blue solution. Our copper carbonate to begin with, this is one of the ones you need to know, is a green solid. So our green solid disappears. We also get a bit of heat given off here, not huge amounts of heat in this one, okay, and we get a blue solution from a green solid. Okay, so just be cautious of that one there, guys, when they throw a transition metal one into the mix. Alright, the last one that I want to do, just as a wee sneaky one that pops up every now and again, is ammonia with, doesn't really matter which, we'll use our methanoic acid again, and we will get ammonium methanoate this time. Now remember, when you react ammonia with an acid, you only get a salt. There is no carbon dioxide, there's no water produced. That's the one that catches people out there. They insist on trying to get water into this, maybe, probably not carbon dioxide, but water. Okay, that does not happen with ammonia, if you remember back to your acids last year. Now, observations here, well, you get a bit of heat here. Okay, the solution here is a colourless solution, there's nothing. You start off with a colourless solution anyway. The big observation here, and this is what catches a lot of people out, is that originally ammonia has a very pungent smell. Now, the ammonium then has no smell. So actually what happens is that the smell disappears. Okay, so you actually lose the smell. Okay, so that's your observation on that one. Same as it was whenever you did the same thing with strong acids last year. Okay guys, so make sure you do the questions in your textbook, okay? On those pages that I told you at the start, it goes up to page 214 and it starts there on page 210. That's in the textbook, and make sure that anything that's in your notes, you've got those filled out as well within your notes. Okay, so we're nearly done with the organic chemistry. There's only really one more video to go. Okay, so hopefully you understand this, and make sure you do your reading of your textbook, your reading of your notes, and get everything filled out.